Everybody, welcome back to this series, this videos. Today, like I said the last time, okay, this is a 001. This is MTH 001, and like I said the last time, we are going to be looking at logarithms today. Well, the logarithms we'll be looking at is the exacting type, and we'll just be looking at the introduction so that we don't cram ourselves. Excuse me. We don't cram the whole space up and not being able to get much out of it. So today we'll just look at the basics of logarithms, then a few examples, then I'll give you some exercises. So logarithms. Logarithms, okay. So the definition is that the logarithms of a positive number is defined. Okay, positive number n to base a is defined as the power of a which is equal to n. Which is equal to n. Okay. Now let's look at examples. So what he's saying is that logarithms of a positive number, say n, is to the base of a is defined as that power of a. Whatever you are going to raise a to, that will give you n. So that is logarithms. So for example, if you have 3 as your base number, and let's say a, which is the base number, is 3, and n, which is the positive number, is 9. Then logarithm of 9 to the base of 3 is going to be that number that you are going to raise 3 with 2 to give you 9. All right, so what will you raise 3 to give you 9? That is 2. That is, so we can now conveniently say that since 3 raised to the power 2 equals 9, okay, since 3 raised to the power 2 equals 9, then log 3 9 equals 2. Okay, so which you can generally write as if a raised to the power x, if a raised to the power x equals n, all right, then log a n will be equal to x. Okay, log a n will be equal to x. So this is what you should know very well, all right, and keep. Now let's go to another one. This is a little bit weird. So we say since 9 raised to power half, that's the square root, equals 3. Okay, then what does that tell us? It means that log of 3 to the base of log of 3 to the base of log of 9, sorry, to the base of 3 is actually uh, half. Okay, that's just it. Okay. Oh, sorry. That's a mistake on my part. I'm so sorry about that. It's actually log. Okay, obviously 9 is the base now. So what will you power 9 with to give you 3? That will have to be half. It means that you are taking the square root. It means that the power of 9 to give you 3 is a half. That is power of 9, which yields 3 is 1 over 2. Okay, now let me save this page. Okay, let's look at another example. Let's look at another example. Yeah, another example here says that we should look at let's say since 4 raised to power 3 equals 64, then it means that this is the base, this is the power, this is the number. So if we rearrange it, then we say the log of 64 to the base of 4 is in fact 3. Okay, so these are the things we should know. These are the things we should know. Now there are these laws of logarithms. Laws of logarithms. So we go to laws of logarithms. Okay, laws of logarithms. So there are 3 basic laws to it. So the first law says if you have log of base a of b times c, then it's the same thing as log ab plus log ac. Okay, log ab plus log ac. Let me see how I can explain that. Well, let's leave it like that. What he's saying is that when you take when you seek the logarithm of a product is actually the sum of the individual log of what you multiply. Okay, that's what it's saying. All right, so something like if you have log say 2 of let's say 25. Okay, it's the same. Okay, let's say 27. Let's say 27. All right, it's the same thing as log 2 of um, 3 plus log 2 over, I think, what can we multiply by 3 to give us 27? I think we should be looking at 9. Okay, so that's what that is saying. So what we have here now is that, okay, will you raise um, what will you raise 2 to give you 3? Well, whatever that is. What will you raise 2 to give you 9? Whatever that is, you lump them together, you get that. So let me look at something much more direct so that we can talk about it more. So let's look at log of 2 raised to 64. 64. Will 64 work? 16 times 4. Excuse me. I'm coming. I'm coming. I'm looking for something that would easily work. Okay, 64 will work. Okay. Okay. If we want to simplify this, we know that it's going to be log 2 into 4 times 16, which according to the law is going to be log uh, 2 4 plus log 2 16. Now, what's log 2 for? What will you raise to the power of 2 to give you 4? That's 2. And log 2 16, what will you raise to the power of 2 to give you 16? I think that is 4. 2 times 2 times 2 times 2. That's 4. So this is 4, which means is 6. That is log 2 64 is going to give us 6 based on this thing we have worked here. Okay, based on this. Now let's check if it is true. What is actually log 2 64? That is, what will you raise to what? Okay, what will we raise? What power will we raise to give us 64? So let's look at 2 times 2 times 2 times 2 times 2 times 2. Of course, this is 8, 8. Okay, this is actually 64, which is actually 2 raised to the power 6, which is exactly what we have there. I hope you understand that. So let me save this page so that we can, look at something else, another law. Let's look at another law. Yeah, let's look at another law. We have looked at the law of multiplication. Let's look at the law of addition. I mean of division. This law says law 2 says that if you take the logarithms of a and we do b over c of it, then it's going to be log a log a b minus log a c. Okay, that's what it's going to give us. All right, so let's look at another example. Let's look at a similar example as what we have earlier. Okay, let's look at uh, okay, let's look at log a. What value can I use now? What value can I use? Okay, log a. Let's look at log a4. Let's look at log a4. This is really interesting. Log a4 is, log 2, sorry, log 2 4 is equal to 2 clearly. All right, since 2, which is the base here, raised to power 2, which is what we are seeking, is equal to 4. Now, another way to write this is in fact log 2 16 over 4, which is according to the law log 2 16 minus log 2 4. Log 2 16 is that number that you raise 2 to give you 16, which is I think that's 4. Yes. And log now minus log 2 4 is that number you raise 2 to give you 4, which is 2. So the answer is 2. So you can see that the law makes absolute sense that way. Now let's look at the third one. The third one is also quite interesting, intriguing. It says that log a into b raised to the power of p equals p log a b. Okay, well, there is a simple explanation for that. There's a simple explanation for that. Let me explain that one before I pick an example of it. This is because this we will apply the first law, the law of product, to this one. So log a into b raised to the power p is the same thing as log a into b times b times b times b. Of course, that will be in a p times. Okay, so if that's the case, then it means that we are going to have log a b according to the product law, log a b plus log a b plus log a b. That's in a p times. So if you repeat something p times, then it's the same thing as p times that thing that you are repeating, which is log a b. So that settles that. Now let's seek out an example. An example of that. Let's look at log 2 into let's say 4 raised to the power 5. Okay, if you look at log 2 equals 4 raised to the power 5, so this is telling us that it's going to be 5 log 2 4, which is going to be 5 times log 2 4 is 2, which is going to be 10. So if you open up this, whatever this is, that's 4 times 4, 16 times 16 times 4, whatever that gives us. If we solve the log, this is what we're going to get. So you can see the essence. Instead of us to be doing this big number, we can just apply the law and it gives us a solution directly. I'm saving the page. Okay. All right. So let me look at one major example. Something quite fascinating. Okay. Then I'll give you some exercises, some of which are quite tough. So we'll talk about those ones later. So it's the example. This example says, I think I can. So I'm actually almost through with the introduction class. So I don't want us to do too much so that we don't lose total interest in it. So let's do it little by little and see how far we can go with it. So example. So we say show that log a into a squared minus x squared is in fact 2 log a into 1 minus x squared over a squared. Now, there are two ways I can do this, but then I think I should just, well, actually it's not two way. Solution, let's look at the solution. Solution says that log a into a squared minus x squared is actually the same thing as, well, without changing anything, we can just, let's put a square bracket here, bring out a squared here, and this will be 1 minus x squared over a. That's actually not difficult. We have applied something like this before. So this is the same thing now as log a into a squared. You can now see this is a product, all right, plus log a into 1 minus x squared over a squared. All right, now let's look at this guy. So what will you put as a base? I mean, what power of base a will give you a squared? That's of course 2. All right, because if you square the base, then you get the positive number a squared. So this is definitely 2. Okay. Okay. 2 plus um, okay, that's 2 plus 2 plus log a into 1 minus x squared over a. All right, so which is the same thing as the question. Oh, sorry, the question is, sorry, this is 2 plus. All right, sorry. So this is the final answer. Okay, so I think that is enough introduction. I think that's enough introduction. Okay, I've actually been talking for like 21 minutes, which is okay. Let's look at some exercises. Okay, so we have question 1, which says you should evaluate the following. So 1, evaluate the value of log 3 27 327. 2, evaluate the value of log 1 over 3, that's the base, 27. Okay, now again number 3, evaluate log 2 16, that's 3. 4, evaluate log 1 over 2 32. Okay, number okay okay number 5, evaluate the log of x raised to power 3. Okay, then maybe let's look at number 6 here. Okay, I think log y raised to power 3 y. We should look at that. Then log 1 over x x6. That's a number. This is 5. This is 6. Then this is 7. Then 8. That's the 8th one. I think that's a log. Okay, I don't think I have that one correctly. So let's play around with these ones. All right, and let's see what you can come up with. As I said about 002, this is a group assignment. All right, so I would expect to see your solution. Please, if you have any problem on our last discussion on partial fraction, let me know. And if you have any problem on this class I just delivered on indices and on logarithms, let me know. I really don't think anybody would have much problem with indices, but then if you still do, let me know as well. Yeah, thank you very much. Let me save the page and sign out. Okay, and today is I think 18th of Thank you very much, and God bless you.